Hi, I'm Doug Erwin from the Smithsonian's National Museum of Natural History in Washington, D.C. I want to talk today about past biotic crises and how they may be relevant for this meeting. This is an image of a place called Meishan in South China between Shanghai and Nanjing along the Yangtze River. It's a place I've been studying with my colleagues at the Nanjing Institute for more than 20 years now, almost 30 in fact. This is how it looked a long time ago. The red line demarcates something called the end Permian mass extinction, one of the largest biotic crises of the last 600 million years. If we were to walk up through the section along this hillside, we'd see species gradually disappearing from the fossil record. And we'd see the same thing in records at localities all over the world. We've studied Meishan because the record here is more detailed than almost anywhere else. This is a diagram showing the disappearance of species. As we walk up through this section, there are about 330 species here, many grouped into different clades. And this shows a very rapid, indeed a catastrophic extinction close to the boundary. Just an image to show what some of the transitions look like between the latest Permian to the left of the screen with flourishing ecosystems, the earliest Triassic after the extinction with very low diversity, and then later in the early Triassic, an increasing number of species begin to return to ecosystems in various parts of the world. The end Permian mass extinction is one of many events that happened over the last 600 million years. There are 5 canonical great extinctions that are talked about in the press and among paleontologists. This slide shows the diversity of marine organisms over the last 600 million years. And the red arrows show these 5 great mass extinctions. One at the end of the Ordovician, about 440 million years ago, a slow decline during the Devonian, this great end Permian event, and then one at the end of the Triassic, and the famous one that killed the dinosaurs, non-avian dinosaurs, at the end of the Cretaceous 65 million years ago. It's important to note that this record is based upon durably skeletonized, abundant marine taxa, similar to some of those, the exquisite fossils shown in this slide. We use the marine fossil record because these taxa are abundant, they're geographically widespread, so we're likely to find them preserved as fossils, and they have to be durably skeletonized. They have bones or shells or hard parts so that we can recover them and record their past history. That kind of record produces this outline, this sketch of past biodiversity crises. It's not that plants and insects and vertebrates on land aren't important. We simply don't have the resolution in the fossil record that allows us to look in detail at the timing and the nature of the events, although the record for all those other kinds of fossil groups is much better than it was a few years ago. A more detailed look at this kind of data shows that these biodiversity crises go far beyond the 5 that are popularly known that I showed on the previous slide. This shows 18 events over the same period of time, the last 600 million years, that are outlined in red, each of which has heightened extinction relative to the surrounding intervals of time. This is a slide from a paper that I published with my colleagues in South China in Science in January this year, showing the very high resolution record from China, essentially the entire Chinese fossil record for the period between about 540 million years ago and the great end Permian mass extinction that I've been talking about on the right, catastrophic drop. And you can see that there are many ups and downs and squiggles superimposed on this line, showing that biodiversity crises happen at different scales. Some of them are these catastrophic events, some of them are much smaller. During these events, we know that they're selective in different ways. Some taxa are more likely to go extinct than others. The reasons for these selectivity are not always clear. Often they seem to have to do with metabolism, with geographic range, or other factors. but they do provide clues that are important for understanding the nature of these mass extinctions. And we can identify a number of common features of these events. They're geographically widespread. They're found essentially globally, often both on land as well as on the sea. They're selective in that particular groups are affected more than others. And there's a common underlying cause, in most cases, of rapid climate change. This is a slide or an illustration from Siberia. It shows a massive flood basalt known as the Siberian flood basalt that covers an area almost the size of the continental United States. It erupted rapidly, and we're fairly convinced now that this is the major cause of the end Permian mass extinction, this event 251 million years ago. These massive flood basalts are one of the leading causes of these past mass extinctions. In general, the mass extinctions are associated with climate changes, particularly global warming, and often oceanic anoxia, loss of oxygen, particularly in shallow waters. But the ultimate causes are these incredibly massive volcanic eruptions. And in one case, at the end of the Cretaceous, impact of an extraterrestrial object. One of the important features of these events, though, is that the context matters. Not all massive volcanic eruptions have caused severe mass extinctions, and not all impacts, because they vary in size and where they hit, have caused mass extinctions either. So where these events and the nature of the Earth system at the time they occur plays a very important role in the size of the events. This is an illustration showing the distribution of these flood basalt provinces. You can see that many of them are quite massive in size. The Siberian flood basalt one is huge. Some of the other ones are much smaller and had much less, possibly no real biotic consequences at all. So in summary, mass extinctions and biodiversity crises have been ubiquitous in the history of life, at least the history of life we know over the last 600 million years. The primary cause of these events has been rapid climate change, most commonly triggered by massive volcanic eruptions. We have relatively suggestive evidence that resilience to extinction during background times, the intervals between these mass extinctions, often enhances survival during great mass extinctions. And that may be of some relevance for this conference because it suggests that fostering resilience during so-called background intervals may also guard against or enhance survival during global catastrophes. Thank you.